Hello, good day everyone. So today we're gonna report about Chapter 7 entitled Network Architectures. So the learning objectives are, first, to understand the different major network architectures including 10 megabytes per second Ethernet, 100 megabytes per second Ethernet, Gigabyte Ethernet, Token Ring, AppleTalk, FDDI, and ATM. Next is to understand the standards governing network architectures. And lastly, to understand the limitations, advantages, and disadvantages of each standard or architecture. Ethernet. During the late 1960s and early 1970s, many organizations work on methods to connect several computers and share their data. One of these projects was the Aloha Network at the University of Hawaii. From this research, Robert Metcalf and David Boggs, researchers at Xerox Palo Alto Research Center or PARC, developed an early version of Ethernet in 1972. Then, in 1975, PARC released the first commercial and early version of Ethernet, which allowed users to transmit data at approximately 3 megabytes per second and up to 100 computers with a maximum of 1 kilometer of total cable. Xerox teamed with Intel Corporation and Digital Equipment Corporation in an industry group which is known as the DIX, that stands for Digital, Intel, and Xerox, which is to develop a standard based on Xerox Ethernet and raise the transfer rate to 10 megabytes per second. In year 1990, the IEEE used this version of Ethernet as the basis for its 802.3 specification, which defines how Ethernet networks operate at the physical and data link layers of the OSI model. Overview of Ethernet. So Ethernet is a popular network architecture with many advantages. First is the ease of installation. Next, it is low cost. And lastly, its support for different media. Each of these architectures, such as AppleTalk, ATM, and FDDI, shares similar methods for packaging data into frames and uses baseband signaling. Nearly all versions of Ethernet transmit at 10 megabytes per second or 100 megabytes per second, but more recent standard supports transmission at 1 gigabyte per second or 1000 megabytes per second and 10 gigabytes per second or 10,000 megabytes per second. Features include packing data into frames, using CSMA or CD channel access, and using hardware, the MAC address. And Ethernet is divided into 3 categories based on transmission, speed, and media. 10 megabytes per second IEEE standards has 4 major implementations. The first one is 10 base 5, which uses thick coaxial cable. Second is 10 base 2, which uses Thinnet coaxial cable. Next is 10 base P, which uses unshielded twisted pair cable, and 10 base F, which uses fiber optic cable. From these four major standards, only the 10 base T and the 10 base F are commonly seen today. 10 base T Ethernet uses category 3, 4, 100 base T. It is also called as a fast Ethernet. It is an extension of the 10 base T standard. Grand Junction Networks, 3Com, Intel, and other modified the 802.3 Ethernet standard to support 100 megabytes per second transmission over Category 5 UTP. The current IEEE standard for 100 base T is 802.3. 100 base T has three substandards. First is 100 base T4 that has 4 pair category 3, 4, or 5 UTP. Next is 100 base TX, a 2 pair category 5 UTP. And lastly, the 100 base FX, 2-strand fiber optic cable. 100 base T has 2 types of hubs. The first one is class 1, may have only one between communicating devices, and the other one is the class 2, may have maximum of 2 between devices. So figure 7-2, it shows here the switches interconnecting multiple hubs. And in this table 7-3, it shows here the summary of 100 base T Ethernet. Gigabyte Ethernet, a 1 gigabyte per second IEEE 802.3 standards. It is collectively the IEEE identifies various gigabyte Ethernet standards under the general heading 1000 base X. 1000 base X requires different signaling methods. It uses 8 bytes or 10 bytes coding scheme with 8 bytes of data and 2 bytes of error correction data. And it uses full duplex mode. There are 2 separate extensions that covers 1000 base X and 1000 base T. The first one is 802.3 in year 1998, which covers 1000 base X including L, long wavelength laser or fiber optic, S, short wavelength laser or fiber optic, and C, the copper jumper cables. Next is 802.3 AB in year 1999, which covers 1000 base T requiring 4 pairs of 100 OHM Category 5 cable or better. 10 gigabyte Ethernet, 10 gigabyte per second, IEEE 802.3 AE standards is anticipated ratification in late 2002. It runs only on fiber optic cabling and it uses both single mode and multi-mode. It has a maximum length of 5 kilometers. It uses full duplex. It is likely to be used as network backbone and in storage area networks or SANs. And it enables to scale from 10 megabytes to 10 gigabytes speeds. What's next for Ethernet? The future of Ethernet is bright and fast. Implementations of 40 gigabytes Ethernet are underway. Estimations are the Ethernet could increase tenfold every 4 to 6 years, giving us 100
Hello everyone, I'm Haramina Mary Esno, and this is the continuation of Chapter 7, which is the network architectures. So let's move forward to Token Ring. So Token Ring is developed by IBM in the mid 1980s. Token, Token Ring network architecture provides user with fast, reliable transport. So the token ring it provides the the users a fastest and reliable network. The next is wired in physical star topology. Functions as logical ring. See figure 7, 6 and simulation 7 to 2. So next is this is the image of token ring physical star functions as logical ring. So the figure 7 and 6 is token ring networks have a physical star topology but function as logical ring. So next is the token ring function. Uses of token ring function channel access method. Token ring networks ensure that all computers get equal time on the network. Next is a computer receives the token from its nearest active upstream neighbor or NAUN. If the token is not used at the time, no nearby computer is sending data, and the computer has data to send. It attaches its data to the token and sends it to its nearest active downstream neighbor or NADN. Also, the function of token ring is it provides equal access to all computers, uses larger packets between 4,000 and 17,800 bytes with no collisions. So it means that not colliding. Next is originally operated at 4 Mbps, but newer version increased speed to 16 Mbps. So the newer version has updated and new rapid speed of the of it. Next is Next is beaconing. So technique automatically isolates faults. First computer powered on network becomes active monitor managing beaconing process. The first computer powered on a token ring network is assigned the responsibility of ensuring that data can travel along the ring. So the data can travel along the ring. This computer, the active monitor, manages the beaconing process. All other computers on the network are standby monitors. Packet announces address of active monitor. Network is intact if packet travels around network and returns to active monitor. Figure 7 shows ability to reconfigure network to avoid problem area. So this is the token ring reconfiguration to avoid break. Figure 7 shows that this this figure will help to avoid troubles. Next is the hardware components. Uses manifestation multi-station access unit or MAU or MSAU or smart multi-station access unit SMAU. Next is the ring out or RO port on one hub connects to the ring in or RI port on the next hub, and so on to form a ring among the hubs. So there is a interconnection of the RO to RI to connect or to form a among the hubs. And next is IBM's implementation of token ring allows 33 hubs to be connected in this fashion. With the original token ring hubs, this provides a total of 260 stations per network. However, newer hubs that allow 16 computers per hub double this number. So, the new, when we say new, so it's being it's being updated, and the systems, the networks, and the rapid what do you call this, the rapid and fastest transporting networks or data is and it's also, it doubles the number compared to the current or former. So next is the cabling in a token ring environment. So in 1984, IBM defined a comprehensive cabling system that specified cable types, connectors, and all other connectors components required for computer networking. This cabling system breaks cables into different types based on the American Wire Gauge or AWG standards that specify wire diameters. So let us see Table 7 to 8 and Table 7-9 summarizes token ring. So this is the Table 7 to 8, which is the IBM or token ring cabling. So the cable types, we have type 1 to 9, and it's this following description. So type 1 is TP with two pairs of 22 AWG solid copper wire surrounded by a braided shield and casing. This cable is used to connect computers to MAAUs and can be run through conduit or inside walls. Type 2 STP with two pairs of 22 AWG solid copper wire for data and four pairs of 26 AWG wire for voice. This cable is used to connect both data and voice without running two cables. So this type 2 used to connect the both data and voice without running the two cables, or uses the two cables. Next is type 3, which is it is said that UTP voice grade cable with 22 AWG for 24 AWG, each pair twisted twice every 3 to 6 meters, 3.6 meters or 12 feet. It is cheaper alternative to type 1 but limited to 4 Mbps. This can be a alternative to type 1 but and less expensive. So next is the type 5, which is fiber optic cable 62.5 or 100 micron diameter. It is used for linking MAAUs over distance. So this the type 5 used to for over MAUs over distance or has farther location. Next is type 6, STP cable with two twisted pairs of 26 AWG stranded wire surrounded by braided shield and casing, similar to type 1, except that the stranded wire allows greater flexibility but less distance, two-thirds that of type 1. This cable is generally used as a patch cable or for extensions in wiring closets. So this is used for wiring closets or extensions. Next is type 8 STP cable for use under carpets. It is similar to type 6 except it is flat. So the type 8 can be useful too to many things. Type 9 plenum rated type 6 cable. So next is the summary of token ring, and this is the table 7 to 9, which is there's a category and its summary. So the IEEE specification is said at 802.5, and its advantages of the token ring is fast and reliable. Yeah, as what I've mentioned earlier. And next is the disadvantages of the token ring is more expensive than Ethernet. difficult to troubleshoot, so it is more costly and it's hard to troubleshoot. Next is topology, ring cabled as star. Next is channel access method or token passing. Next is maximum cable segment length, 45 meters UTP and 101 meters STP. Next is maximum number of segments, 33 hubs. Maximum devices per segment depends on hub. Maximum devices per network, 72 with UTP, 260 with STP, and the transmission speed is 4 Mbps or 16 Mbps. Next is the AppleTalk and ArcNet. So let's define first what is AppleTalk. It includes a number of features that allow local area networks to be connected with no prior setup or the need for a centralized router or server of any sort. So, Apple Computer Inc. designed the AppleTalk architecture for use in its Macintosh networks. Um, if I'm not mistaken, this is developed by as what I've mentioned is developed by the Apple, the one that is trendy, and this so meaning to say they're very um, techy, updated, and um, I IT or computer enthusiasts, and as we all know, many people around the world is really fond of Apple and its varieties of gadgets that they produce. Sometimes yearly or monthly, or we don't know. It depends on the availability of their product and what they produce. And many people are very fond of it. ArcNet rarely used today. As its introduction, AppleTalk referred to the networking protocols and the hardware used to connect computers. So this is the hardware where to connect computers. In 1989, Apple changed AppleTalk's definition to refer the overall architecture of the network and added the term local talk to refer to the cabling system. Simple, easy to implement network architecture uses built-in network interface on Macintoshes. So wow, built-in is amazing. And next is AppleTalk refers to overall network architecture while local talk refers to cabling system. So we now know the difference of the AppleTalk. Again, AppleTalk is for network architecture and local talk refers to cabling system. Next is uses dynamic addressing scheme. Computer chooses numeric address and broadcasts it to make sure it is unused. Next, so this is the continuation of the Apple environment, and next is the phase 1. The original version of AppleTalk, now referred to as AppleTalk Phase 1, supported only 32 computers per network, and even those could use only local talk cabling. Including hubs and repeaters increased the number of computers to 254. So as the time goes by, if that network will be updated and new, so the computers will be plenty or having more and more. When Apple next is the phase 2, which is was in 1989 it introduced EtherTalk and Talk, which allow Apple Talk protocols to operate over Ethernet and token ring networks respectively. This increased the number of computers that an AppleTalk network can include to more than 16 million. So that would be the end of my topic, and before I end it, let's wrap it up. And I just want to review or clarify some important key terms or um, vocabularies or definitions of my topic that I was being discussed earlier. So let's have a quick review. I just want to um, clarify. So beaconing, the signal transmitted on a token ring network to inform network computers that token passing has stopped due to error. Next is local talk. The cabling system used by Macintosh computers support for local talk is built to every Macintosh. Next is multi-station access unit, an active hub in token ring network. Next is nearest active downstream neighbor, used in a token ring environment to describe the computer to which a computer sends the token. Next is nearest active upstream neighbor, used in a token ring environment to describe the computer from which a computer receives the token. Token ring, a network architecture developed by IBM and which is physically wired as a star but uses token passing in a logical ring topology. Lastly is token talk, the standard for sending Apple Talk over token ring cabling. So that's it, guys. I hope you have learned something new or a little bit of my discussion, and thank you for listening.